Every single time you open Instagram, check your bank account, or buy something online, your data travels through hundreds of servers across the world. Most people assume it is safe, but here is the truth. Without HTTPS, anyone sitting on the same Wi Fi as you can read everything you send, your passwords, your messages, your card details, everything. So, how does HTTPS actually protect you? And why do most developers use it every single day without truly understanding what is happening underneath? That is exactly what we are breaking down today. By the end of this video, you will understand HTTPS better than most working developers. Let us start with the problem that HTTPS was built to solve. Before HTTPS, the web ran on plain HTTP. And HTTP has one massive flaw. Everything you send is in plain text. That means when you type your password into a login form on HTTP, that password travels across the network as raw, readable text. No encryption, no protection. Anyone who can intercept that network traffic can simply read it. This is called a man in the middle attack. You are talking to a server, but someone in between is silently reading everything. On public Wi Fi, like at a cafe, an airport, or a college, this is incredibly easy to do. A basic tool called Wireshark lets anyone capture and read network packets in minutes. This is the problem HTTPS was designed to solve completely. So, what is HTTPS exactly? HTTPS stands for Hypertext Transfer Protocol Secure. It is simply HTTP with an extra security layer on top called TLS, which stands for Transport Layer Security. You might also hear the older term SSL, Secure Sockets Layer. SSL was the original protocol. TLS is the modern, more secure version. But people still use SSL and TLS interchangeably in conversations. TLS does three things. First, it encrypts your data so no one can read it in transit. Second, it authenticates the server so you know you're talking to the real Instagram and not a fake copy. Third, it ensures data integrity, meaning no one can modify your data without you knowing. Encryption, authentication, integrity. These three things are what HTTPS gives you. Now, here's the part that most developers do not fully understand: the TLS handshake. Every time your browser connects to an HTTPS website, before any actual data is exchanged, the browser and server go through a handshake. Think of it like two people agreeing on a secret language before having a private conversation. Here is exactly what happens step by step. Step 1: Client hello. Your browser sends a message to the server saying, "Hello, I want to connect securely. Here are the encryption methods I support." Um, Step 2: Server hello. The server responds, "Great, I choose this encryption method. And here is my SSL certificate so you can verify I am who I say I am." Step 3: Certificate verification. Your browser checks the certificate. Is it signed by a trusted authority? Is it expired? Does it actually belong to this domain? If all checks pass, the browser trusts the server. Step 4: Key exchange. Now the browser and server generate a shared secret key together. They do this using a method called asymmetric encryption. They can create the same key without ever sending it across the network. This is the clever part. Step 5: Secure communication begins. From this point on, everything is encrypted using that shared key. Your password, your messages, your payment details, all encrypted. Even if someone intercepts it, they see only random meaningless bytes. This entire handshake takes less than 100 milliseconds. It happens automatically every time you visit an HTTPS site. Let us make this real with an example you use every day: Instagram. When you open Instagram.com, look at the top of your browser. You will see a small padlock icon. Click it, and you will see certificate is valid. That padlock means the TLS handshake happened successfully. Your browser verified Instagram certificate, established an encrypted connection, and everything you send, your login, your messages, is now encrypted. The certificate is issued by a certificate authority, a trusted organization that verifies Instagram is actually Instagram. Major certificate authorities include companies like DigiCert, Let's Encrypt, and Komodo. Uh, If you ever visit a site and see a warning that says your connection is not private, that means the certificate is invalid, expired, or missing. That is your browser telling you the TLS handshake failed and the connection is not secure. Never enter any sensitive information on such a site. Every major platform you use, YouTube, Twitter, Gmail, your bank, they all run HTTPS. It is not optional anymore. In fact, Google Chrome marks any HTTP site as not secure in the address bar. So let us quickly recap what we covered today. HTTPS is HTTP with TLS security on top. TLS gives you three things: encryption, so no one can read your data; authentication, so you know you're talking to the real server; and integrity, so no one can tamper with your data in transit. The TLS handshake happens in under 100 milliseconds every time you connect to a secure site. It is invisible to you, but it is protecting everything you do online. And that padlock in your browser, it is not just a decoration. It is proof that your connection is encrypted and the server is verified. Now, here is my question for you. Have you ever actually clicked that padlock and looked at the certificate? Drop yes or no in the comments below. I will read every single comment. And if you want to go deeper, next week I am covering exactly how databases decide where to store your data and why getting this wrong destroys your app performance. You do not want to miss that one. See you in the next video.